my name is Joshna from the Agora Math Circle. Today we are doing Senior Beginner Session 5, and we will be going over equations and inequalities. So in this lesson we are going to learn expressions, solving linear equations, word problems, and finally inequalities. Let's start with expressions. So when you combine numbers or variables using mathematical operations, you get an expression. So let's look at this expression right here, 6x plus 10. And let's break it down into its parts. The first part is a coefficient, and a coefficient is a number that is right before a variable. So the number 6 is right before the variable x, so that makes 6 a coefficient. Next, let's look at constants. So a constant is a number that is all by itself, or is a term by itself. So if we look right here, 10 is all by itself, and that makes 10 a constant. Next, terms. So a term is a part of an expression that is separated by either a plus sign or a minus sign. It can't be separated by multiplication or division, only plus or minus, addition or subtraction. So if you look right here, we have a plus sign, and that is our operation. And whatever's on the right, which is a 10, is one term, and whatever's on the left, which is 6x, is another term. So 6x and 10 are terms, and they're separated by this plus sign right here. Finally, we have variables, and variables are letters that can represent values. So our variable right here is x, and it's easy to spot it because it's a letter. So x is our variable. And now a really important thing to note is that expressions don't have equal signs. So if you look right here, there's no equal signs in front of this expression. Equations, however, do have equal signs. So don't mix up expressions and equations, because expressions don't have equal signs, but equations do. Now let's look at this example, and let's try to find the parts that are in this expression. So x squared plus 6x plus 9. So first let's find coefficients. Alright, so we already know that 6 is a coefficient because it's right in front of the variable x, right? We also know that there's a little coefficient right here in front of the x squared, and that coefficient is 1. And that's because any variable multiplied by 1 is a variable itself, right? So that's why you can imagine that every single variable that is alone has a little 1 in front of it. So that's why 1 is a coefficient and 6 is a coefficient. Next, let's look at some constants. So if you look right here, look for any number that's all by itself or its own term. Well, right here, 9. So 9 is a constant. Next, let's look at the terms, or the parts of the expression that are separated by a plus or a minus. So if you look right here, we have the x squared, we have the 6x, and we have the 9. And those are the terms. And finally, let's look at some variables. So the only variable that we have is x. And here x is squared, and here x is multiplied by 6. So x is our variable. And those are the parts of an expression. Now let's find out how to compare two expressions to see if they're equivalent. So what you want to do is find out if they're equal for every value of the variable. So let's look at these examples. X plus 7 and 7 plus x. Are they equivalent? So the first thing I want to do is try to plug in a number for the variable. So let's say x equals 1. So if we do x equals 1, we get 1 plus 7 and 7 plus 1. And both of those equal 8, and that means that they are both equivalent. And remember, you have to make sure that they're equivalent for every single value for the variable. So you can try x equals 1, x equals 2, all the way up till 3, 4, 5, infinity even. And we know that if every time we do it, they're going to be equivalent. So that means that x plus 7 and 7 plus x are equivalent. Now let's look at 1 over t and 2 minus 1 over t. So I'm going to plug in a number for t. Let's say 5. So if I do 5, we have 1/5, and 2 minus 1 over 5, which is equal to 1 over 5. And I know they're equivalent, and I can try it for every single number, and they'll still be equivalent. So I know that 1 over t and 2 minus 1 over t are equivalent. Next, let's look at 12x over 4 and 3x. So let's think of a number. I'm going to say x equals 2. So then we can say that 12 times 2 equals 24, and 24 divided by 4 equals 6. And then 3 times 2 equals 6. And we know that those two values are equivalent, and we can try that for every single number, and we know that they'll still be equivalent. Finally, r squared over r and r. So let's think of a number for r. Let's say 4. So 4 squared, which is 16, divided by 4, is going to equal 4. And r is just going to be 4. So 4 and 4 are equivalent. And we can do that for every single number and still find out that they're equivalent. Okay, so now let's move on to simplifying expressions. So when you simplify an expression, you're trying to make the expression as simple as possible. So to do that, let's do some examples. 5x plus 6x. So what you want to do is really important. You want to combine like terms. So when you combine like terms, you want terms that are similar to each other. For example, two terms that have the same variable, or two terms that are constants, and you want to combine them. So if they have an addition symbol, you want to add them, subtract them, multiply them, whatever you can do. So there's add or subtract them. So if you see here, we have 5x plus 6x. 5x plus 6x. So 5x is a term and 6x is a term. And we know that they're like terms because they both have the variable x in it and a coefficient before. So we can add 5x and 6x to get 11x. And that is our simplified expression. Now let's look over here. 7x minus 8. Alright, so our terms here are 7x and 8. And we know that they're not like because this has a coefficient and this is just a constant. And that means that there's nothing we can do to make it more simple. So this is already simplified. So for 8a minus 3 in parentheses minus 23 minus 5a in parentheses, the first thing that we're going to do is distribute this minus sign to the numbers in this parentheses. So let's do it to the 23 and to the negative 5a. So that turns this into minus 23 plus, because it's minus minus, 5a. And now we can combine like terms. So our first set of like terms is 8a and 5a. And we're going to add them because there's an addition symbol. So 8a plus 5a is going to equal 13a. And then what we're going to do is subtract minus 3, or negative 3 minus 23, which is the same thing as saying negative 3 plus negative 23, which is negative 26. Now what you can also do is you can take away the 13. We can take away the 13 from the a and 13a and the negative 26. So that will be 13 times a minus 2. And then we can show that that's true by saying that 13 times a equals 13a, and it's going to be 13 times negative 2, which is minus 26, and it's shown right here. And these two are equal, so your answer can either be this right here or this. Now, for 5r minus 6 plus 4r minus 1 plus 9 minus 3r, each of these in its own parentheses. So the first thing you want to do is see if we need to distribute a negative symbol, like right here. And it looks like we don't have to since there are plus signs. And now we're going to combine like terms. So our first set of like terms are 5r, and then plus 4r, and then it's going to be plus negative 3 because plus times a negative is just a negative, so minus 3r. And then what you're going to do is look at the next set of like terms, which is the constants. So you're going to look at negative 6, and then we have, after that we have negative 1, so minus 1, and then we have plus 9, so plus 9. And what does that equal? Well, first let's combine the like terms. 5r plus 4r minus 3r, what does that equal? 6r. And then, it equals 6r. And then what you're going to do is look at the negative 6 minus 1 plus 9. And what does that equal? Plus 2. So again, you can leave your answer like this, or you can say that you can take out a 2 from each side and just say that it's 2 times 3r plus 1. And both of those are correct. So you can do either one. You don't have to pull out the 2, but if you want to, you can. Now let's look at expanding expressions. So when you expand expressions, you're trying to make the expression bigger. And to do that, you want to use the distributive property. 7 times y plus 2 in parentheses. So, first thing you want to do is distribute the 7 to the y and to the plus 2. So that's 7 times y, and then 7 times positive 2, which is going to be plus 14. And that is our expanded expression. Now let's look at 8d times d plus 3 in parentheses. First thing you're going to do, multiply the 8d here, and then to the positive 3. So 8d times d is just going to be 8d squared, because d times d is d squared. And then you're going to do 8d times positive 3, which is just plus 24d. And that is our expanded expression. Next, we're going to do x plus 2 squared. So for x plus 2 squared, what you're not going to do is just apply the square to the x and then to the 2, saying x squared plus 4 squared. That is not correct. The first thing we're going to do is we're going to separate out the parentheses. So x plus 2 and then x plus 2. And then we are going to do the FOIL method, as we learned from the last lesson. FOIL. So that means first, which is going to be x times x squared. Then outside, which is going to be x times 2, so it's going to be plus x2 or 2 times x. Then we do the inside, 2 times x, and then finally x times 2, so that, 2 times 2, which is going to be plus 4. Then combine like terms, and we get x squared plus 4 plus 4x plus 4. So our answer is x squared plus 4x plus 4, and that is our expanded expression. And finally, for expressions, we are going to look at how to express a multi-fractioned expression as a single fraction. So, if you look here, our first example, we have a over 2 plus 6a minus 5 over 4. And you can see that these two terms are being added. And as you know, when you add two fractions, the first thing you want to do is make sure the denominators are the same. So to add these two fractions and express it as a single fraction, what we want to do is make the denominator the same. And when whatever we do to the bottom to make the denominator the same, we have to do to the top. So whatever we do to the denominator, we have to do to the numerator. So, first thing we can do is try to turn this 2 into a 4, or 4 into a 2, but I think making it 2 into 4 is easier. So, what you're going to do is multiply by 2. So we get 2 times 2, which is 4. So I can rewrite this as over 4 plus 6a minus 5 over 4. And remember, whatever we do to the bottom, we have to do to the top. So multiply the top by 2, and we get 2a. And now we can express this, or add this, and express it in a simplified form. So 2a plus 6a minus 5 over 4. So we can also say that it's the same thing as this. Over 4. And now we just add like terms. So we get 8a minus 5a over 4. And we are good. So this is our simplified answer. Now let's look at here. 2x plus 7 over 6 minus 9 minus 2x over 9. First thing I want to do is make the denominators the same. How are we going to do that? Well, let's look. 6 and 9. What can I do? I know if I multiply this by 3 and multiply this by 2, I can make both the denominators 18. And whatever I do to the bottom, I have to do to the top. And since this is a whole expression right here, 2x plus 7, I'm going to do parentheses to make it easier for me. Do over here, so times 2. So now, let's do this. So we get 3 times 2x plus 7, what is that? 6x plus 21 minus 18 minus 14, and we want to combine like terms. So 6x plus, or it's going to be minus 4x, that's going to be 2x, and you're going to have 21 minus 18, and that is over 18. And this is our final simplified answer, which is a single fraction, 2x minus 3 over 18. Now let's go on to solving linear equations. So an equation states that two quantities are equal. For example, a plus b equals b plus a. And a linear equation basically means that if you have a variable, for example x, it's only to the first power. So you're not going to have x to the second, x to the third, just x to the first power. Now, to solve equations, what you're essentially trying to do is you're trying to isolate the variable to find the solution. And there's two ways you can do this. You can replace an expression with an equivalent expression, or you can perform same mathematical operations to both sides of the equal signs. So you can either do one of these things or do both of them. So let's look at these examples right here. X minus 12 equals 289. So the main thing that you're trying to do is you're going to isolate the variable or make the variable all by itself. So to do that, what do you need to do? Well, I need to add 12 here, right? Because if I add 12 and subtract 12, they'll cancel each other out. It'll just be plus 0. And then whatever I do to this side, I have to do to this side. So I did a plus 12 here, which just crossed these out, and then a plus 12 here. And so that means that x equals 301. And that is our answer. X equals 301. And that's what it means when it says solve. You're trying to find what x equals or what the variable equals. Now let's look at this example. U over 7 equals 3 over 14. So the main thing you're trying to do is isolate the variable. How are you going to make this variable all by itself? You're trying to basically do the opposite operation of what's already in it. So you have u over 7, so divided by 7. And to cancel out the 7, you want to multiply by 7. Right? Cancel that out, and then whatever you do over here, you have to do over here. Multiply by 7. and then we know we can simplify. So this equals 3 over 2. So u equals 3 over 2. And that is our answer. Our next example, 4 times t minus 7 in parentheses equals 3 times 2t plus 3 in parentheses. So first thing you want to do is distribute the 4 here. You're going to expand the expressions on both sides. And then make it here, so t, 6t plus 9. So now we have 4t minus 28 equals 6t plus 9. Now you want to combine like terms. So pretty much what I want to do is make the variables go to one side, and then all the other numbers go on the other side, right? So one thing I can do is I can move the 6t to this side, and I can move the 28 to this side. How am I going to do that? Well, I know I have to add 28, and I know here I have to do the opposite, so I have to subtract negative 6t. So this is going to be 4t minus 6t equals 28 plus 9. What's 4t minus 6t? That is negative 2t equals 28 plus 9, that is 37. And then so you have 2t equals negative 37. Next thing you want to do is say t equals, and then divide this side by negative 2, divide this side by negative 2. So that's going to be 37 divided by negative 2. You can also say that it's just negative 37 divided by 2. And that is our answer. Now for our last example, we have 2r minus 7 over 9 equals 3. So you want to isolate the variable. First thing you want to do is get rid of this 9. So I'm going to multiply by 9. To cancel it out, multiply this side by 9. What do I get? This is going to be 27. This is going to be just 2r minus 7. Then I'm going to add the 7, and I can do two things at the same time. I can add the 7, and right after that I know that I have to divide by 2. Cancel out. So I'm going to add this side by 7, add this side 7. What do I get? 34. And then I want to divide by 2, so I can divide the 34 by 2 to get 17. I know that r equals 17. Now, before we finish, we want to make sure that whatever we get is correct. So what you can do is plug whatever you get for the variable back into the original equation. So let's say for r equals 17. What's 2r? That's 34. 34 minus 7 is 27. So 27 divided by 9, that is 3. 3 equals 3, you're correct. Now let's look over here for t. So negative 37 over 2, I know that if I plug it in, I'll get the right answer. Same over here with the u, and same over here with the x. And that is how to solve equations. So when we were solving the equations before, we always had a solution, and there's always one solution. X equals something or r equals something. But what can also happen is that you can have infinite solutions or no solutions. So when you have infinite solutions, that is basically when two sides of the equation are equivalent. And that means that any single number can work for the variable. 1, 2, 3, all the way up till infinity. So we have infinite solutions. And when you have no solutions, that means that the variable cancels out and both sides are not equal. So for example, if you say that 4 equals 12, that does not make sense. So that's why there's no solution. So let's look at some examples. Here we have 5w plus 3 minus 2w equals w minus 8 plus 2w minus 3. First thing we're going to do is combine like terms. We're going to get 3w and then plus 3, which equals, we'll combine like terms here, so w plus w is 3w minus 11. Now we need to bring the variable to one side. So what I'm going to do is move this over here and move this over here. Add 11, and I'm going to subtract 3w. Well, when I do that, I get 3 plus 11 equals 3w minus 3w. And then this means 3w minus 3w, that just equals 0, right? And that means that 3 plus 11, which is 14, is going to equal 0. And 14 does not equal 0, right? So that means that there is no solutions. And that's what I'm going to write. No solution. So let's look at this next example. 2z minus 8 minus 5z equals 2 minus 3z minus 10. So, combine like terms. 2 minus 5z, what is that? Negative 3z minus 8, which equals 2 minus 3z minus 10. We combine like terms. It's just going to be negative 3z. 2 minus 10, that's going to be negative 8. So right here. Oh, wait a minute. Negative 3z minus 8, negative 3z minus 8. They're both equivalent. That means that any value we put for z, and it's going to make sure that these two expressions are equivalent. So we can say z equals 1, z equals 2, anything. So all the way up till infinity, so that means that there are infinite solutions. Next, let's go over word problems. So when you're doing word problems, what you're essentially trying to do is convert the words to math. So here are the steps. First, read the problem carefully. Next, convert the words to math. Then, solve the math, convert the answer back to words, and finally, check your answer. So here are some terms that can help you. Usually when they say a number, that means it's a variable. And when they say more or increase by or add, that means plus. And if they say less, decrease by, or subtract, that means minus. There's also terms for multiplication and division. So let's look at these two examples. First, 7 more than twice what number equals 35? So what you're trying to find is, so you're going to do twice a number, and then add 7 to that, and it has to equal 35. And now it's asking you for that number. So we're going to do just like what we did before. We're going to isolate the variable. So minus 7. Does that equal 28 2x? And then divide by 2. Divide by 2. And then x equals 14. Next, a garage has 17 cars and motorcycles. Altogether, there are 56 wheels. How many of each type are there? So first thing you know is that a car has 4 wheels and a motorcycle has 2 wheels. So you're going to write that. And we know that there's a total of 56 wheels. So we know that since every car has 4 wheels, and we know that we're going to do C for car, and we know that every motorcycle has 2 wheels, so 2 times m for motorcycle. We know that that's going to equal 56 wheels in total when you add them up. Next, we know that the garage has 17 cars and motorcycles. That means when you add the cars and the motorcycles, you get 17. So now, this is the type of equation that we have to solve by substituting whatever we have here. So we're going to substitute an expression of what we know. So what I'm going to do is I'm going to move the m to this side. I'm going to say c equals 17 minus m. And I'm going to use this c right over here. So the new equation is going to be 4 times 17 minus m plus 2m equals 56. The m equals 6. And then it's asking me for how many of each type are there. So we know that there's 6 motorcycles. And now, since I know whatever this is, I can plug this back into either this or to this. So since I know m equals 6, and let's just do this. 17 minus 6, that's going to make c equal 11. So now there's 11 cars and 6 motorcycles. And that is our final answer. So when you're writing this down, it's important to have units. This one doesn't need units, but this does. So we know that there's 11 cars and then there's 6 motorcycles. To finish off inequalities, here are some rules. So, if A is greater than B and B is greater than C, then A is greater than C. Same goes for greater than or equal to. Next, if X is greater than Y, and then X plus C is greater than Y plus C for any number C. Similarly, if A is greater than B, then X plus A is greater than Y plus B. And it's the same for greater than or equal to. And next one, if X is greater than Y and A is greater than 0, then XA is greater than YA. Same goes for greater than or equal to or less than or equal to. And finally, if we multiply or divide an inequality by a negative number, that means we have to switch the sign or change the directions of the sign. For example, if you have negative 1/2 A is greater than negative 8 right here, and you want to isolate the variable, you are going to multiply by negative 2, right? So multiply by negative 2, to cancel this out, multiply by negative 2. But since we're multiplying by a negative number, we have to switch the signs. So this is negative 16. So make sure you switch the signs when you're multiplying or dividing by a negative number. And what's another important point is that any of these inequality rules work for positive numbers, but whatever works for positive numbers doesn't always work for negative numbers. So keep that in mind. So before we're finished, I want to go over a really quick challenge question. 3 times 5 minus 2y in parentheses greater than or equal to 2y minus 9. let's see if this is true and find y. So first we're going to do is distribute 3. So this is going to see 15 minus 6y is greater than or equal to 2y minus 9. Next we're going to collect like terms. So we want to bring, let's say let's bring the y here and bring the numbers here. So what you have to do is you're going to have to add 9 up here, add 9, and here we have to add 6y. So 15 plus 9, what is that? 4 greater than or equal to, and you're going to add 6 here, so we get 8y, and then we get y is greater than or equal to, so we divide 8 here and divide 8 here, divide by 8, divide by 8, cancel that out, we get 3. So y is, so 3 is greater than or equal to y, or another way to write it is that y is less than or equal to 3. And that is our solution.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!